Welcome back to the workshop here at Naval X in Alexandria. This session is on integrating autonomous systems in challenging areas of operation. And it's focused on the autonomy challenges facing dynamic areas of operation, including global areas that are a little different from ours, and local community complexities. How can rapid innovations like this, events like this, help these communities ingest and adapt to autonomous systems? Now, I make no pretense about being an expert in this field, so I'm thrilled to welcome our guests here with us today. They are joining us via Zoom, and I believe I have Mr. Chris Hegney from Fourth Fleet with us, and Mr. Joel Young. I will have our guests, hello guys, take a minute to introduce themselves and tell us a little bit about why this topic matters to them. We'll start with you, Mr. Hegney. How are you doing today? Oh, we might have oh, there we are.
So I think Chris might be having challenges logging in. This is Chris Murphy, the HACKtheMACHINE Science Advisor.
Chris Murphy, who is a science advisor with ONR Global. Can you tell us a little bit about then what you're doing? And we will go right over to Joel after. But what are you doing these days, and why does this interest you?
Absolutely. So I'm the science advisor to the commander of the U.S. Pacific. And this is an ONR Global position that is really meant to facilitate the push and pull of technologies from the Navy Research and Development Enterprise and the operational fleet. And today's topic is incredibly relevant because autonomous systems are really reaching that level of maturity where they're coming off of the lab benches and they're getting into the water, and they're available for us to start experimenting with and writing into our doctrine and tactics for how we envision using these systems to enable warfighting capabilities in the near future. Looking forward to the discussion. Thanks.
Awesome. And Mr. Young, thank you for joining us today. Can you tell us a little bit about you and what you're doing and why this topic interests you?
Yes, I'm an analyst at U.S. Indo-Pacific Command in the Joint Innovation and Experimentation Division. I'm working on counter UUV technology.
Awesome. Excellent. All right. Well, while we wait we have a couple guests.
A lot of people will look at the parallel.
Okay.
Okay. Real quick. A lot of people will parallel the counter UUV situation to the much more mature counter small UAS situation.
Oh, I see a third has joined us. Do I have a Chris Hegney?
Looks like Sam Royster there.
Do we have audio? Can you hear me? Or is that Sam Royster?
Yeah, this is Lieutenant Royster.
Oh, hi, there we go. Okay. Sam, you are joining us. You are your MPS, right? The Naval, I believe, Naval Postgraduate Studies, is that right?
Yeah, Naval Postgraduate School.
Yes. And I actually met you via LinkedIn, and you had done some really cool work with AI. Can you tell me why this topic is of interest to you and what you're doing? And recently won an award for.
Yeah, so I was invited to participate based off of just presenting at the Naval X Challenge Summit in 2021 and winning that pitch competition based off of my pitch to use like man-unmanned teaming in robotic hull cleaning, so hull husbandry operations, just as kind of a field where before we fight with these vehicles, we kind of can get all our lessons learned in an easily more controlled environment, like for maintenance and that kind of stuff, and then we can take those lessons learned and use it for like mine hunting in offensive environments later. Just use it once we build these tools that are going to be helpful for maintenance. So
awesome. So let's talk about this. We're going to people who are watching this who may not have the same military background or the same information or experience. Let's kind of walk them into this conversation a little bit, right? So when we talk about a dynamic area or a challenged area, we mean areas that we will operate in that we don't control all the pieces and parts in. We're not the only people there, and we may even have some some constraints on our movement based on political or socio-geographical concerns happening in areas. So a dynamic or challenging domain means that we don't get to set the rules for everything that we need to do in that environment, right? And that comes with its own default set of challenges just operating in that today, right, with manned systems that we combat. So if you think about that from just that basic start, what does autonomy, adding in autonomous systems and autonomous, especially complete autonomous platforms, what does that add into that challenging, that challenge sphere? What are the things we're looking at that we're concerned about or we need to get after? And anyone's free to answer first.
Yeah, I'll jump in here. So the mission of Indo-PACOM and Pacific Fleet is really to ensure free and open Indo-Pacific, and to build relationships and capabilities with our allies and partners. And what makes that challenging, probably first and foremost, scale. It's easy to see how big our area is on the map, but we lose sense of, what a line of sight from a 6-foot tall mast looks like in the middle of the Philippine Sea. On the average map, if I took the dot from the tip of my pen and put it on the map, that's probably what that individual system can see. So really respecting sort of the tyranny of distance out here. We also have a really diverse set of missions. Everything from humanitarian aid and disaster relief to, making sure we can field and sustain high-end warfighting capabilities in the region. And within that, there is a whole different subset of missions, all of which require unique capabilities traditionally done today and overseen and managed by, thinking and intelligent, highly trained human beings. And so when we think about autonomous systems and how they're going to integrate in, we need to, make sure that we don't lose sight of the question that we're trying to answer. It's very unlikely today that there's any single solution that can replace a fully trained, officer or crew or ship in the Navy. And so scoping expectations and solving problems one at a time, I think, is a reliable way to respect unmanned and autonomous technologies that are maturing, while giving them the flexibility and maturity to be valuable outside of the labs, outside of our harbors, operating forward.
All right. I would have never guessed all of that, but good. That's a great start. Mr. Young, and we have another person joining us, I think. Oh, we have someone on the phone.
Sorry, I just turned my video on and off.
Joined via phone.
Awesome. Okay. Can you repeat from the phone who is it? Who we have?
Chris Ferragni just joined from the phone
hi.
from
Yes,
Naval Forces Southern Command and the 4th Fleet.
Excellent. And before we were just talking about just some of the basic challenges that autonomy introduces into these dynamic areas. But Chris, Mr. Hackney, can you tell us why this topic matters to what you're doing over at 4th Fleet?
Yeah, absolutely. So, there's a push towards autonomy for the entire Department of Defense, and the Navy's use is many things, right? I mean, the DoD writ large is used as many things, right? If I can remove a manned person from a risky environment, then I can shift that risk onto some machine that can go and perform maybe even more risky things. So I can buy down the human cost of conflict. So there's that, kind of big picture, reason to go to autonomous systems. It's also very expensive to train people, right? If we look at how much it costs to train pilots and things that are skilled enough to do the missions that we need, it costs a lot of money to invest in those assets as human operators. So if I can defer some of that cost into machines that I can train, that is a way to increase our combat power with while decreasing cost, right? So those are some of the big pictures. But for us in the SOUTHCOM, U.S. Southern Command AOR area of responsibility, which is South America, Central America, and the Caribbean, we've really got to come up with cheaper alternatives to provide intelligence, surveillance, and reconnaissance. That's a big gap that we have. We have a whole lot of ocean to cover. We have very few assets to do it. So how can we get after that problem in a kind of creative new way, realizing that, we're not going to, have some huge flush cash, tons of money to go spend at this problem, tons of ships, tons of airplanes. We're just not going to get that in this AOR. So what can we do? What can we do differently? And autonomous systems is really one of the key solutions for us that will allow us to have, increased maritime domain awareness at a lower cost point. That's really what we're trying to deliver for the commander. Over.
Excellent. Okay, so in terms, we're talking about, you're already in a dynamic or a challenged area of operations, right? And then we know what that means when you have we have a pretty good idea of what that means when you have a manned system. You're adding in autonomy. We've talked about what those additional autonomy challenges adds to that conversation. So if we know that it's already challenging and we know it's already hard with manned systems, and now we're adding in the addition of autonomy, how are we going to, what are the key indicators or the key things we need to start thinking about to integrate this autonomy into this? Because it's not just, like I said in the beginning, it's not just us, right? We're affecting other partners, and we're potentially putting ourselves more at risk with people who are kind of challenging us in the different domains. And I'll add to this that autonomy, on the Navy side, is not just going to be applied abroad and afloat. We have ashore pieces of autonomy and autonomous systems being integrated into our life cycle, and there's some challenges there too. You can even go out to the shipyards and things and have those, on the port side, and say, hey, you can't just put autonomy wherever you want. So I'm interested in kind of what your thoughts are on how we approach the topic of integrating in these domains.
Yeah, that question was for me, Christopher Higgins.
I'm sorry, say that again, sir?
Was that question for me?
Well, that's for anyone. So you're all welcome to answer. If you've got an answer, that's great. I'm also looking at Mr. Young is here on the call with us. I have Chris Murphy, who is the science advisor from ONR Global, with I'm going to say the wrong fleet. I just know I am. And then I've also got Mr. Sam Royster, who is recently an awardee, who's at the Naval Postgraduate Study School here with us. So you weren't here when we did introductions, sir. So they're all on the call. So when the questions are open for everyone to jump in on.
All right, wonderful. This is Chris Hegney. So I'll take a first swing at that, and I'll give a very specific example of something that's hurting our head today. That's probably one of the number one things, if not the number one thing, that I am focused on trying to solve. And so when we talk about challenging operating areas, we think about things like GPS denied or degraded environments, or comms denied or degraded environments. And so the biggest piece that is going to enable that autonomy is onboard processing, right? How we kind of do it now is you have a remote operator, you launch a UAS, for example, or an unmanned surface vessel or something, and there's a human that's still controlling that. There's a lot of autonomy built in, right? The airplane flies itself, right? It can keep its wings level, it can adjust to wind gusts, it can fly to a waypoint. If it drops a comm signal, it can perform some pre-planned maneuver. It does a lot of that autonomy piece, but we still have a human integrated with that command and control of that aircraft. Now, some of that's technically, we need it for technical reasons. Some of that's policy reasons, right? We don't necessarily want to make everything completely autonomous and take the human decision maker out of the kill chain. But one of the big technical pieces that we really need to solve is that onboard processing capability. There's a big difference between having your Roomba automatically, vacuum your floor and having Terminator decide which person to shoot, right? And so the onboard processing piece is really critical And obviously, as we, advance microelectronics and miniaturize the size, weight, and power requirements, we're gonna get there, right? Processing power is gonna increase and all that good stuff. So I think that happens naturally. But one of the things that we really need to focus on right now to solve the DoD's problem is the ability to detect and avoid obstacles or things that you're going to collide with. So for example, in the unmanned aircraft space, say I fly an aircraft out, 200, 300 nautical miles out into the sea, and it's out there performing its mission, doing whatever it's doing. Well, if that aircraft, runs into a passenger airplane and hundreds of people die, that's bad news, right, for the people on the airplane, but it's bad news for the Navy. It's bad news for what we're trying to do, right? That sets us back. So the operational commanders, at least in the Southcom area of responsibility, don't have an appetite to do that. So unless we have the ability for that aircraft to be able to detect its surroundings with either onboard radar or onboard electro-optical systems or onboard acoustic detection systems, right? Think of all the things that humans bring, all the sensors we bring, eyes, ears, all that stuff. If the UAS doesn't have an ability to detect its surroundings and dodge another aircraft that it's going to collide with, a lot of times operational commanders won't employ that aircraft outside of an air traffic controlled space. And so when we're talking about way out in the ocean, there's no air traffic control out there. So we're really limiting ourselves to kind of coastal operations or some operations where there's a ship that's got this big radar that's radiating. So we really need to get away from that, and onboard processing is the answer. So this specific example about the ability to detect and avoid reliably on unmanned systems, that is something critical that we need to tackle like right now if we're going to deploy these things in outside of air traffic controlled space.
Okay, so I mean, I totally understand everything you just said. Sam or Joel, do you have any thoughts about the onboard processing tools? Sam, I know this is like an area of you've been doing a lot of work on thinking about. So, and Joel, I'm not sure what your depth of knowledge is on this, but I'm interested in other thoughts on do we have solutions ready for this, or how quickly can we get after this problem?
No, that is a good question, and I agree. It's Chris, right? At
Yes.
Southcom?
Mr. Hegman?
Yeah.
Yep.
Yeah. I agree with a good portion of what you said there, that a lot of the autonomy is going to be dependent on sensors and how good are the sensors that you're going to use in an environment. In some cases and applications, we might not be there yet. Specifically, I'm looking at underwater in the littorals and ports and harbors. So the acoustics is a very difficult problem in those environments. Do we have enough information? Are the sensors good enough is one of the questions.
I think it's in addition to the onboard processing, like limiting the amount of bandwidth required to pass back to higher headquarters. It's a data, like machine learning can't happen without groomed data sets. So without the military, the situations that these vehicles are going to run into are like very discrete, and then there's limited opportunities to gain data about them in any instance, right? So a Waymo self-driving car can log 10,000 hours trying to make left turns, and it still struggles, right, to make that decision of how much, will I be able to make this left turn without crashing into the oncoming traffic? And they still struggle with that, and they've been able to do 10,000 hours. How do we get that data set and to be large enough that the machine can then make that decision when it's deciding whether hostile intent is being displayed by an adversary, right? So those being able to glean those data sets, right, and then or figure out how to artificially generate them and then put them into our rules-based systems so that the systems can accomplish machine learning is also a big challenge, right? So we, going back to what Chris talked about, even just in the maintenance aspect, right, which isn't that hard of a problem, right? All I'm trying to do is clean grass off of the side of ship hulls. But in order to accomplish the inspection, right, the vehicle needs to be able to look at the entire side of the hull, identify where there's grass, where there's paint, where there might be damage, where there's barnacles that maybe the brush is not going to be able to remove. And while there's a lot of pictures out there, none of them have been, no one has gone in and made object detection boxes, right, for all of those different types of features. So like that data set doesn't exist. So I can't train my robot to look for those things because the data set doesn't exist, right? So we have to figure out what questions does the robot need answered in its rules-based system, and then what data set then would support it being able to make those decisions, and then we have to basically groom and generate those data sets. So it's you can't put the cart before the horse. If you put the greatest sensor in the world on the system, but it isn't able to make a decision based on that system because it has no data to base its logic off of, right? It's not going to be able to accomplish its mission.
Awesome. Okay, so if I'm hearing you and I know I am hearing you correctly, is that you've got the data set issue, we've got a bandwidth processing issue, and kind of a processing on the edge, right? Like what can you do on these small form factor, a lot of times autonomous systems, or in these to process there without having to send it back to home, or if you're especially in a denied area, you can't send it back to home. It's got to make some decisions right there. Ultimately, these all tie back to trust, right? The ability in an active mission, which probably won't, I mean, it could be all autonomous systems out executing a mission, but you're probably looking at a hybrid approach, right? Where you've got a mixture of manned and unmanned systems. You have to trust it. You have to trust that it's making the right choices and you've sent it out and it's going to be able to make the right decisions that are out there. So even if we get after the bandwidth and we get after the processing and we get after some of the data sets, how do we achieve that part where we're able to trust it in this environment and trust what it's sending back as well when we can't maybe not have eyes on or it's been out there for a long period of time, and especially in these, again, more dynamic and challenging areas of operation?
Hey, this is I'm getting a lot of static. You guys hear that too, or no? Is that just me?
How about now?
No, I guess it's getting a little better. This is okay. It went away. This is Chris Fragney. So let me take another quick shot at that question. So I think what makes it really difficult for us is we're in the business of killing people, right? And so that's a high bar of accepting accuracy deviations. So for example, if you look at like the post office has for years been sorting mail with an optical character recognition photo scanner, right? So I write my address on where I want my letter to go. I send it through. It scans 1 million pieces of letter a minute, or whatever it does, and then it says, okay, it reads my terrible handwriting, it deciphers what I mean, and it automatically routes it to get on the right truck to get to the place that I want it to go. So we've been relying on autonomous systems for a long time, and the risk of failure in that case is what my letter goes to the wrong truck, and then eventually it doesn't get delivered where it wants to go. It comes back, and then a human falls back and reads that and says, oh yeah, no, I just read the wrong thing. Here's the address, and puts it in the right sorting bin, right? So the risk matrix is a likelihood and consequence, graph. So even if I get the likelihood all the way down, if the consequence is very high or very low, that's going to change my risk tolerance for accepting this automation technology. So in our case, if my mail goes to the wrong house, it might not be a big deal, but if I shoot somebody, that's a big deal. And so I think our ability or the tolerance for mistakes when we're talking about life and death decisions is going to be much, much higher in this arena than it is in maybe some other industry problem sets. So I think that it's going to be very, very difficult if we're talking about solving a problem of, making decisions to drop bombs on targets or not in an automated way. That's probably, a bridge too far for the policy question that you asked, for now, right? But I think there are definitely things that we can do, like like looking at targets in the ocean and sending them back to a human to have the human validate, or looking at the side of a hull and having the computer recommend places to blend and fill out corrosion. Things like that are absolutely things that we could autonomize today. And then as we as a collective world see more and more of those successful lower consequence applications for autonomy coming out, I think that our tolerance for getting higher and higher and higher reliance on autonomous decision making will improve. Does that make sense? Over.
That's a good point. Christopher Murphy, I think you were about to chime in.
Yeah, I think the original question was about trust. And I will highlight in April of this year, Pac Fleet partnered with the Office of Naval Research to bring essentially the, I won't say best of breed, but a well-represented set of unmanned or autonomous systems to San Diego for what was called the Integrated Battle Problem 21. If you're not familiar with it, I highly recommend you Google it. There's some great photos out there, some great articles that were written about what we were doing, why we were doing it, and what we learned from. And one of the most, probably permanent impressions that I walked away with from that event was sailors and autonomous systems and how they evolved over the course of 2 weeks. And there are discrete examples of unmanned systems with, I would say admittedly, in many cases, limited autonomy being given to a sailor, obviously with supervision and training to use. And the way that they evolved, how they thought about these systems was interesting, because it went from something that kind of sat on the side or was used sort of, outside of the sphere of how we normally do things, to integrating into, established SOPs and tactics, doctrine. And that's all within a little bit of experimentation within 2 weeks. And so it's important in the trust building realm to build familiarity. And to build familiarity, you have to get products out there. If we continue to focus on monolithic programs, projects, systems of systems, get out there, it's always tomorrow. And the problem is tomorrow never comes. So creating, defining your minimum viable products, getting it out there, experimenting with it, learning from it, and feeding that back into the labs, the companies, the organizations building these systems is incredibly important. And that trust and autonomy ultimately comes back to building trust and relationships between the operators and the humans that are building those systems. So
let's pull that thread a minute, because one of the things that Sam talked about earlier was having the right data sets and the breadth of data you need so that the machines can learn, right, so that you can then trust them. And it sounds like, how are we going to be able to do that, especially if we're inviting industry and non-traditionals to help us along the way? And we don't give them our real data when we're out there doing these things, or if their systems are gathering it, sometimes their systems don't talk to each other and they're not on the same networks or the same, there's some technical connections, right, that have to be there, and some ways of building those data repositories. Is that an activity that we're actually doing right now, or are those things we need to get after?
Well, yes, this is Chris Hagney. I'll answer that one as well. So it depends on the activity, right? So in full motion video target detection realm, right? That's a high area of investment for the DoD. The Office of Secretary of Defense has a program called Project Maven that invests in building those labeled data sets. So they take footage from manned and unmanned aircraft and satellites and surface vessels, all kinds of stuff. They take that footage, they'll send it out to human operators, and human operators will do the image processing, right? Where they'll look and they'll say, okay, we're looking for buried IEDs in the sand in Iraq. So they'll take all these pictures of buried IEDs, they'll draw boxes around where the IEDs were, and we'll have labeled data sets that we can then provide to industry and academia to go and develop target recognition, computer vision algorithms. And then Project Maven has competitions to see who's got the best algorithm to find buried IEDs, for example, or in our case in Southcom, semi-submersibles in the water, or go-fast boats on the surface of the water, right? So that type of work is being done for things like full motion video. There are data sets that I physically have that I've provided to our industry partners to do similar things that are unclassified. So sometimes we'll use these unclassified data sets as surrogates. We see which algorithms are the most effective for finding what we want, and then we pull that into the higher levels of classification and test efficacy at in classified spaces. Over.
Okay. So are we saying that we're doing the work? We just, it's going to take a little time to build up build up that entire ecosystem to have that trust, or do we still have areas where we're going to need some help in actually integrating these systems in external to the activity we currently have ongoing in the Navy?
So I think that part of the answer there is that we live in an inherently data sparse environment, right? People will have data sets. People can make up data sets. We can spend a lot of time and effort there, but we're going to have inherent gaps in that data. And so one of the tools and the capabilities I think can help out is to be able to look at an algorithm or whatever, sort of machine learning architecture you're building, and to look at the available data sets and make recommendations for what data would be required or needed in order to provide better answers, provide more statistically accurate or relevant answers. And that then can drive, people who generate those data sets to go out there and explicitly look for, more pictures of boxes and IEDs in the sand. You can make up, an infinite number of different applications. But because we don't do a good job of collecting and storing any and every piece of data today, being able to target those collections is important. And underpinning all that is we don't have a workforce that speaks AI, ML, data science, however you want to label it. And so because of that there's a lot of decisions based on PowerPoint deep knowledge. So we have to educate our workforce in order to understand not just the importance of data and that it's important, but what elements of data and how that specifically applies to the technical sciences that underpin the ultimate results.
Any other thoughts on that? I know that some of you are in the RDT&E community specifically, and Sam, you're at MPS. Are those communities getting after some of the more cutting edge or the ideas of how we build some of the solutions from inside, or even integrating with academia and industry from where you sit to go after some of these?
I mean, there's some interesting technology to take a single photo and then basically generate artificial data set from just that single photo. So there is like a way to try and train a data set to predict or get a training data set based off of a very limited amount of data. You can kind of expand it by rotating and changing the color and kind of predicting what the other side of the aircraft looks like based off of, or like ship looks like based off of just our own like human knowledge of what that system should look like. And then I think just from an operator perspective, as a former submariner, I mean, kind of understanding the limitations of the system that you're operating with is also very important. So I mean, like, in I don't know, going back to the whole cleaning robotics, right? Right now, the vehicles that are being deployed today can only accomplish about 80% of the cleaning, and they can't do the niche surface areas. So they can't clean like the rudder and propeller because it's just kind of a weird shape, and the vehicle is just not really designed to do that. So like when you deploy that vehicle, you just kind of know that 20% of the solution it's going to have to be supported by human-machine teaming, right? So it's just kind of explaining the bounds of the problem and the system's capabilities to those operators, and then they can kind of figure out the best way to accomplish the rest of the mission, right? So if you're deploying with some sort of unmanned service vessel that's able to detect stuff passively via sonar, but it's not really able to do complex target motion analysis, right? The human operator can provide those inputs into that system, right? And it still reduces bandwidth and expands your sensor range. So just kind of understanding what limitations are, what data is being fed into the system, and what the limitations of the output that it's providing are is important. And I don't think that operators are not able to learn that and understand that. I think that's the key to building that trust, is kind of trusting the operators to know the limitations of the systems that they're deploying with.
Okay. So one of the reasons that we do this at Hack the Machine, we have these conversations, right, is to get help and to have these rapid innovation challenges, get militarily applicable solutions back out. So, this is part of a continuum. We're going to, continue with this Hack the Machine unmanned series for a couple, and we're going to do some in person and have some systems in the water with us, and we're going forward. If you were looking at, hey, the future of what I would do in a rapid innovation challenge to try and get us moving forward, what would you ask for?
Real quick, I kind of like Sam's idea of, can you use extrapolate from human instinct to create your data set? The things that you see with your eyes, and you can turn it in all different directions and orientations, and you still know what it is. And to create that data set, otherwise you do it manually.
All right. Any other ideas or thoughts that would get us towards
this is Chris Hagney. I have one.
Sure.
Oh, I'm sorry. Go ahead.
Well, I was just going to give an example that I used to go into meetings before where they were doing explosive detection, and sometimes the question is, would you rather have the technology or the military working dog? And the guys that work military working dogs in EOD never say they want the technology because it's not as good. And so can you make your AI as good as the dog? And in some cases, maybe a lot of cases, the human is the best classifier today.
That's a good benchmark.
Chris, let me give an example I think is pretty important and something that could be done today in partnership with industry. If you imagine I have a human that comes on to a deployment, and they're gonna serve on in the backseat of P8, and they're gonna be looking for surface targets. They come on, and their ability to find the targets that are in that theater that they're flying in is not very good. They're a novice. As they're in this 2 or 3 year deployment to the theater, they get really good at finding the targets that they want to find that operate in that theater. They get to understand the pattern of life. They get to understand, what the geography impact is on the sensor returns. They just get really good at it. And at the end of that 2 years, they're as good as you can get for a human. And then what do? We send them off to some tour in some other place, and we lose all that knowledge. And then we get a fresh new person, and they have to start over again. So there are some inherent negatives of relying on humans to do kind of target detection, analysis stuff. And if we could have a machine learning solution that just continuously gets better year after year, decade after decade, eventually it's going to get really, really good at finding all sorts of things in all sorts of environments. And so I think that's really the carrot, right? That's why we need to do this AI ML thing more. So if you look at kind of where industry's going and an area that's really going to have huge advances. It's commercial overhead satellite imagery, right? If you look at unclassified imagery that's available today, I can go to Google Maps and I can see my house and I can see how many cars are parked in my house. And that commercial imagery is just going to get better and better and better and better, regardless of military investment. And so processing those images, those commercially available images, unclassified images for things, right? In our case, we're the Navy, so we want to see maritime things. That is something that industry could do for us today and continuously improve as, new satellites, new sensors, new things are put into space. That's all unclassified. And so if you think about things like doing things that we do today, like pattern of life for ships. So, you could go on Google and find out where are Navy ports for, threats around the world. And you can look at those unclassified, satellite pictures and say, okay, well, how many ships do they have? And what are the pattern of life for those ships? And where do they go patrol? And when did they go do it? What did they do? That type of analysis could be done right now. And that type of analysis could be done 5 years from now with the enhanced commercial imagery that's coming out. And so that's the kind of thing where industry could absolutely engage and do that and bring capability to the DoD that the DoD may or may not have. And at price points that the DoD can afford, right? That's the other big piece. So we really need to look at things like that we could be doing right now, and maybe invest in those. Over.
Great.
Yeah, for some of these challenges in innovation, gatherings moving forward. One of the, and this harkens back a little bit to the integration. It's what we've seen and struggled with a lot out is every time we come across an unmanned system, it is truly a system of systems, and you can break it at a very high level, and you could obviously do this as much as you want into, you have platforms, payloads, C2/autonomy, and then mission planning or planning elements to it. Often, mature solutions bring in solutions, and that highlights that moving forward, in order for us to realize the benefits that we say we want out of autonomous systems, scale and capacity, capabilities with defined mission sets, and we want them to be, cheap as well. In order to realize those, we need to get better at integrating these different and facilitating the integration of these different components. And so, a challenge where you take disparate payloads and platforms and autonomy abilities and figure out the most efficient and effective ways to integrate them would be incredibly value added. If someone comes with a, let's say an unmanned sailboat, says we have this great thing, and as the DoD we say, yeah, well, we want to, squeeze in this big piece of crypto and comms gear. That might not be, something that is sort of a plug and play solution. So the answer is yes, we can do that, but it will take time and money. And now we violated some of those key tenets for why we want to use autonomous systems in the beginning. So figuring out how to take these small disparate components and integrate them in a rapid and efficient way, being able to, it's almost like an API generator, integration, ICD generator. That kind of thing, I think, would really facilitate opening up this space to mix and match the best payloads, platforms, autonomy capabilities, and planning capabilities to give operational commanders flexibility that doesn't require a 20-year, $500 billion program to realize.
Awesome. I think the idea
Hey,
of...
this is Chris Hegney. Let me
Go ahead, Sam.
add to that, because Chris mentioned something that I I think is really, really key for us in the DoD. And it's funny because, the title of this discussion today is integrating autonomous systems in challenging areas of operation. I think you could even remove the whole challenging areas of operation. Let's just talk about integrating the autonomous systems that we have today. That is really, really hard. Even in our own, ranges, even in the lab, it's very difficult. So something that industry can do, and especially this group can do, is help us figure out the government, figure out ways to kind of force like open source architecture, force interoperability of systems. Because we as the government, we a lot of times have, major prime contractors, right? Like the Boeings and the Lockheeds and the Raytheons of the world, those types of people. And they make their money by having us locked into their vendor solution, right? So if I want to have this unmanned system, I've got to get, all of the things, all the widgets, all the stuff that comes with it. And of course, it doesn't play nice with the other unmanned systems that I bought from their competitors. And I mean, that's just kind of how industry works and how, companies work. But it doesn't have to be that way. If you look at things that have been successful, interoperability that's been successful, things like computers, right? Computer standards, a lot of networking standards, all have come together. Companies have come together. They've agreed, hey, this is how we're going to communicate. This is how we're going to operate. And still, even when you look at that, some companies like to try to wedge out some proprietary connectors, some proprietary standards, some proprietary protocol. And smart folks like the people that do Hack the Machine, they'll go through and they'll write a wrapper that'll take that proprietary protocol and genericize it or standardize it. So then us as the government, we could come in and say, hey, yeah, I'm in vendor lock with this vendor, and they're wanting to charge me $1 billion to create this standard, that ecosystem that lets these unmanned systems connect to these other autonomous systems. But I don't have $1 billion. So what can you do, Hack the Machine? How can you help me? Well, maybe Hack the Machine can come in and look at some of these proprietary vendor lock systems and say, okay, I'm going to write you a wrapper or some sort of API or something that lets you plug into that proprietary system and be that interface between the autonomous systems that I have today. That's a huge problem. We've been talking about it for, I don't know, at least 20 years, and we're still kind of stuck. So that's something that I think we definitely could use help from this group with solving. Over.
I think too that like Chris Murphy already said, trying to design a total system solution in the near term is kind of it's always going to be tomorrow because the task is too hard. But like in the near term, right, we don't necessarily we know that there's going to be human machine teaming, right? We know that humans are going to be in the loop or on the loop, right, kind of monitoring these systems. So we don't necessarily need the AI to have the 100% right answer. We just need to know that the AI can be able to know what wrong looks like, right? So we kind of look at 90% of the stuff that we do, or the stuff that we detect on sonar or visually, right, is boring. It's information that's not important for the mission, right? So if we can use civilian data sets to identify boring features, and really then the AI only alerts when it detects something that is interesting, right? Something not boring. And then that basically will reduce bandwidth, operator bandwidth. So we're not having people staring there just sorting through all this boring stuff. They're just looking for those alerts from the AI that they detected something that looks out of the normal, right? And the AI doesn't need to necessarily know what it is at this point and be able to say, hey, that is a enemy combatant, or that is something displaying threat intent, right? We don't need it to say that. We just need to know that all we need at this point in the near term is the ability for the AI to say, hey, this is not normal. I need like human assistance, right, in order to accomplish the rest of that task, right? So it can do 80-90% of all that boring stuff, just sorting through those huge amounts of data, freeing up human operators to either manage more of these systems or perform the higher level cognitive tasks, right, that are important for execution of high level military operations. But the AI is there to reduce the bandwidth in the near term. So using that overhead ship imagery data set or whatever side view imagery of ships, right? The AI could just be there watching, right? And then anytime that it detects something not interesting, right? Like a little CAPTCHA thing could pop up on the screen for the OSS operator, right? And they could be like, oh, I don't know what this is, right? Tell me what this is, right? And then they can kind of validate it. And then the operator there is one refining the data set while they're standing there on watch, but most of their bandwidth is not taken up with being like, oh, that's a class 2 merchant, oh, that's a fishing vessel, right? Because their civilian data sets exist for the that AI to be able to detect that. So the OSS operator then could really focus on only the stuff that's interesting and then helping train the AI while they're sitting there on watch. So I think that would be the bridge in the near term, right? So we can get to once we have that working and the AI is good at detecting stuff that's not normal, then it can work on detecting, like actually refining to the 100% right solution. But first, it just needs to know what wrong looks like. So
I'm going to tie back a minute. And so Sam, I'm taking notes on everything you guys are saying here, and I captured that. But I want to tie back because I have an audience member question here that is asking, so the government has mandated open system standards in other areas like, desktop publishing, Microsoft Word, Excel, et cetera. Sorry? Okay.
This is Chris Hegney. I'm still on.
So the question is, why not mandate a standard for UAV control systems? And these might apply across all UXS systems.
In the last 5 minutes.
I know, and that was a really good point. Hopefully that was still recorded.
I'm not sure if they're hearing me, guys.
Is anybody at Hack the Machine still on here?
Yeah, are you guys not seeing us? Oh, I think we lost them. We're disconnected. All right, well, I will tee up the question for the team, and we will get you guys a virtual answer. We clearly had a technical loss here where
Eric, Nicholas, I see your screen. Can you hear us?
I can hear you. Can you hear me? All right. Well, then we will have to catch up at another time. And I do thank our August panel, Mr. Hegney, Chris Murphy, and Mr. Joel Young, and Sam Royster for joining us on this conversation. It was very interesting. If you recommend it to your friends. And we'll see you again at the next section of the Designer Series.